Okay, we're going to continue to look at addition formulae. Now, so far we've looked at two formulas. That's the two sine ones. Sine A plus B equals sine A cos B plus cos A sine B. And sine A minus B equals sine A cos B minus cos A sine B. Now we're going to introduce some cos formulas now, also given to you in your formula sheet. The first of which is cos A plus B is equal to cos A times cos B plus sine A times sine B. The second of which is cos A minus B equals cos A cos B minus sine A sine B. Okay, so let's have a look at a couple of things we could try with this. Very similar to the lesson on the sine expansions. Okay, so let's have a go at simplifying a few things. Let's go for cos 180 plus x. We're going to simplify that. Okay, so it will be cos 180 times cos x plus sine 180 times sine x. Here's cos 180 and sine 180. Let's establish values for them. So there's y equals sine x, and there is 180 degrees, and as you can see, sine 180 degrees then holds a value of 0. It's on the x-axis. Let's look at cos x. Okay, there's cos 180. That holds a value of -1. So those are two exact values that you should know. So that's going to be -1 times cos x plus 0 times sin x. Well, 0 times sin x, that just goes, and that's just minus cos x. Okay, let's look at example 2. Example 2, let's go for show that cos 75 equals root 3 minus 1 all over 2 root 2. Okay, so again, similar to one that we looked at with sine, 75 is not an exact value that you're given, but you are given ones for example, 45 and 30, and if we combine them together, you would get 75 cos 45 plus 30. So that's cos plus sine cos 45 multiplied by cos 30 plus sine 45 multiplied by sine 30. Okay, cos 45 is 1 over root 2 multiplied by cos 30, which is 3 over 2. These are from the exact value tables. Sine 45 is 1 over root 2 times sine 30, which is 1/2. Okay, multiply these together then, that is root 3 over 2 root 2 plus 1 over 2 root 2. Put them together then, that is root 3 plus 1 over 2 root 2. Okay, let me just point out here that I've made a mistake, which is here. Right, I'd written plus for that bit. It should be minus in between, and I'd written minus in here, and it should be plus. So that should be a minus as opposed to a plus. Should that be? Okay, that doesn't affect that result. I'll still get minus cos x. However, that in there should be a minus. So the key thing is when it's a plus in this expansion, in the middle when you expand it as a minus, and when it's a minus when you expand it in the middle as a plus. So that should be minus, that should be minus, and that should be minus. Okay, next one we're going to simplify cos P cos Q minus sin P sin Q. Okay, so if I just liken that then to cos A cos B minus sin A sin B, well that came from cos A plus B, dead straightforward. So that will just be cos P plus Q. I'm likewise going to simplify this one. Cos 55 cos 35 minus sin 55 sin 35. Okay, so that will come from the cos plus expansion, so that's going to be cos 55 plus 35, which is cos 90, and cos 90 then is equal to 0. That's one of the exact values. Okay, now we're going to simplify cos 75 cos 15 plus sin 75 sin 15. Okay, there's a plus in the middle, so that will come from the cos minus expansion, so it's going to be cos 75 minus 15, that's cos 60, and cos 60 from exact values is 1/2. Okay, next one we're going to verify that cos alpha minus beta equals cos alpha cos beta plus sin alpha sin beta for alpha equals pi over 3 and beta equals pi over 6. Okay, so let's put them in. Cos alpha minus beta, so it's going to be cos pi over 3 minus pi over 6. Okay, so let's have a wee think about what that is. Pi over 3 minus pi over 6. Remember that pi radians is 180 degrees. So pi over 3 is that divided by 3, which is 60 degrees, and pi over 6 would be that divided by 6, which is 30 degrees. So if I do that, take away that, that'll be 30 degrees. Okay, and then what's cos of 30? Cos of 30 is root 3 over 2. Right, so let's just investigate this. Okay, that goes there, that goes there, that goes there, that goes there. There's a minus in the middle, there's a plus in the middle. So it's going to be cos pi over 3, cos pi over 6, plus sin pi over 3, sin pi over 6. And this should arrive at root 3 over 2. So cos pi over 3 then, pi over 3 is 60, cos 60. That's one of the exact values, that's 1/2. Multiply by cos pi over 6, that's cos 30, that's root 3 over 2. Plus sin pi over 3, that's sin 60, that's root 3 over 2. Multiplied by sin pi over 6, that's sin 30, that's 1/2. So that's 1 times root 3 is root 3, root 3 over 2 root 2. Or rather 2 times 2. Try that again, 1 times root 3 is root 3, over 2 times 2 is 4, plus root 3 times 1 is root 3, over 2 times 2 is 4, root 3 over 4 plus root 3 over 4 is 2 root 3 over 4. The 2 over 4 then just simplifies down to 1/2, and that's 1 root 3 over 2, which is root 3 over 2. Okay, let's try ones I might just examine this a wee bit further. Okay, we've been presented with two triangles here, so let's take these down. Two right angle triangles. The first one, I'm told that that's 5 and that's 12, and that is the angle at C. And the next one, I'm told that that is 3 and that's 4, and it's a right angle triangle, and that is the angle at D. Now the question then says, prove that cos C plus D equals 16 over 65. And then the question then goes on to say, find an exact value for cos C minus D. Okay, first move is let's try and find the third side. and that's just a bit of Pythagoras, so I'm going to call that x, and it's the hypotenuse, so it's the longest side. I'm going to add x squared equals 5 squared plus 12 squared, x squared equals 25 plus 144, x squared equals 169, x is the square root of 169, and x is equal to 13. Okay, let's call this one y, and y squared equals 3 squared plus 4 squared, y squared equals 9 plus 16, y squared equals 25, and y equals the square root of 25, which is 5. Okay, cos c plus d, that is cos c times cos d minus sin c sin d. That's where I made the mistake at the start. Okay, so remember SOHCAHTOA. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, tan equals opposite over adjacent. So we're looking for, to get going, cos c. I'll put that up there. So that's going to be the adjacent over the hypotenuse. So there's c adjacent over hypotenuse, 12 over 13. And then looking for cos b, so go to the triangle for, or cos d, I should say. So let's go to the triangle for d. There's d there. Adjacent over hypotenuse, 3 over 5. Then I want sin c, back to the triangle for c. Opposite over hypotenuse, 5 over 13. And then the triangle for d, sin d. Opposite over hypotenuse, 4 over 5. Okay, let's put that in now. So cos c, 12 over 13, multiplied by cos d, 3 over 5, minus sin c, 5 over 13, times sin d, 4 over 5. Okay, 12 times 3 is 36, over 13 times 5 is 65, 5 fours are 20, over 13 times 5 is 65, 36 take away 20 is 16, 16 over 65. Okay, so let's do the cos c minus d bit. So that's going to be cos c times cos d plus sin c times sin d. Okay, so cos c 12 over 13 times cos d 3 over 5 plus sin c 5 over 13 times sin d 4 over 5, multiply top and bottom, 36 over 65 plus 20 over 65, and that will be 56 over 65, final answer.